Hey guys, we are going to do a reaction in a bag, and this is to illustrate conservation of mass. Okay, so how this is going to work is that I've used my kitchen scale here, and I've measured out some mass. So we would do this on our balances in the classroom where we maneuver our weights, but what I have here is I have 20 milliliters of water. I have 2.5 grams of baking soda and 2.5 grams of citric acid. And so what we're going to do here is we're going to be recording the mass along the way. Okay, so I've got my scale zeroed out, and what we're going to do here is I'm going to put my baking soda into my bag, and I'm going to put the citric acid into my bag, and then let's see here. I don't see anything going on. Okay, no reaction so far. And so what we're going to do here is we're going to basically figure out our mass here with our bag and our bowl. Okay, so I've got 137 grams here with my bag and the bowl. And what I'm going to do here is I'm going to get the mass of my water by placing the entire thing in here, but I'm not going to spill the water in yet because I got to get my starting mass. Okay, so our starting mass is 186 grams. 186 grams. So now what I'm going to do here is I'm going to seal up my bag. And then we're going to tilt this. I'm going to bring it up here. And now I'm going to tilt, I'm a little afraid, my water. Woo! There it goes. Get my vial out of the way. Okay, so it's inflating my bag. So as the water has reacted with both of those, so you've mixed water and baking soda before, and you've never really seen much go on. But the citric acid is really reacting with the water there, and it's causing my bag here to inflate. But conservation of mass tells us that even what I start with, I end with. So even though we've had an inflation, we've still trapped all that mass within the bag. So we'll wait until our reaction here ends. We still got a little bit of fizzing going on. And now I'm going to put this back in my bowl. So we started at 187, right? 186, 187, 187. I should have written this down. You write that down for me. You remind me. Okay, and our ending mass, 186. Okay, so just slightly off, and that could be because of how I'm positioning it on the scale. It could also be because of how much, oh, look at how much more it inflated. How cool is that? It could also be how much air was in the bag before I sealed it up. So scientists usually, when they calculate this stuff, yeah, so 186. When they calculate the stuff out, they record a percent error. A percent error. Let me stand in front of that bulb so it's not, right now I'm just like a glowing angel. They calculate a small percent error. They say, yeah, there's going to be a little bit of tweaking here and there. There's going to be, the extra, space in the Ziploc bag or whatever. Sometimes, I bump the table and my balance shifts a little bit. And so they build in for that percent error. But basically what I think is so cool is our 2.5 grams of both citric acid and baking soda are totally gone. All we've got left is our dissolved solution here. But we inflated the bag, so we still captured that in gas form. So we started out with solids. Now we've got our solution here and our gas, and we're still at the same mass. All right, so given this small little display that you've seen with me, plus the video about conservation of mass, you should then be able to answer these 3 questions, just reviewing how conservation of mass works. All right, good luck.